Hello, welcome to my dining room. So I try and keep these videos somewhat short, but we'll have one topic that we'll talk about, and then obviously you guys will have work to do, and we're going to have to be able to communicate at some point in time, but we'll try and go through these notes and then see what we can do from there. So we're going to try and keep all of the Algebra 1 classes together. So we're going to start on the first thing of factoring, which is kind of partway through chapter 9, which is where a lot of us had left off. So first thing we're going to do is talk about greatest common factoring. So the notes that I put up here, these ones are already done out. I think that the concept is something that we've probably seen before or worked with, and hopefully the details will make sense as we go through the routine. In each of these, for example, this first one here, the common factor was 5, and the common factor ends up being written out in front of the parentheses. When we divide out the common factor, what's left over is still in the parentheses. All right. Each of these, as we go through, in this case, 2x squared was the greatest common factor. All right, both of these numbers are divisible by 2. That's the biggest number that they're divisible by. And then both of these have at least x squared in them as the variable. As we look at something that has more numbers and more variables in it, we're still going to take out what they have in common. So 4, 2, and -6, the common number there is 2. We're going to look at the variables themselves individually and then figure out what the greatest common factor is for each of those. All right. One important point, you should have at some point already done the distributive property, and the concept is that I can choose any one of these. If we were to do the distributive property out, we would get the original problem, the original expression back. Okay, so in this case, if we multiplied this out, you could check your answer essentially by what you have written as the factoring is actually the original problem written in a different format. Okay, so your answer should actually be equivalent to what we started with, and hopefully that will be what we work from. So I'm going to give you a couple of options as to how to figure out how to do the factoring. In our first option, I'll call it write out the factors. This is, the most basic way of doing it, and might be something that you can do for a few of the problems, and once you get the hang of it, the second option will be a little bit faster. So the way this works is when you're given a problem, what you want to do is write it out with each individual term written out. So 4 is really 2 times 2, x to the third, x times x times x, and then y squared is y times y. So I wrote every factor out individually. And then over here, 6 is 2 times 3, and then x to the first, y times y times y times y is y to the fourth. So what we're then going to do is we'll look to see what do they have in common. So the common factoring part of this is what comes in next. All right, so they each have a 2. All right, for the variables, all right, they each have an x. I can't circle any more x's because I can't circle any more x's here because I don't have any more x's to circle there. And then for the y's, we'll do the y's. So 1y. I still have another y here. There's another y. So what we have circled is our greatest common factor. So we would write that out, 2 x y squared. So that is the common factor because that's what I was able to circle in each of the terms. And now it's easy to see what's left over from each of the terms. All right. This is 2x squared. All right, so the 2 and then xx was left over, and then here we have a 3 and then yy. So that's 3y squared. So the idea is we're taking out the greatest common factor, writing it in front of the parentheses. Then whatever is left in each of these terms is what's written inside of the parentheses for each problem. Okay, so that's how that one works. If we were to do this second one here, all right, 10a to the third b, so I'd say 2 times 5, a times a times a times b. And then for this other one, see how it says minus 5? I'm going to put negative 1 times 5. This is my style of doing it. All right? It'll make sense when we put everything back together. So again, I'm going to circle the common factors. So for the numbers, it's 5. Sometimes it might be more than one number. For the A's, I'm able to circle 2 of the A's. And then for the B's, I'm only able to circle 1 of the B's because this one only has 1 here. So put that all together, we get 5a squared b as our common factor. And then what's left over here stands out. And I'm going to say 2a minus, see that's why it was important to have that negative 1 there, I know it's minus b to the third. All right, and that's taking out the greatest common factor using our first option, which was writing out the factors. The second option, which is kind of like once you're used to it, you can take a little bit of a shortcut here. Okay, so see in the first one here, I already kind of have it written out, so I'll point out what I did. All right, the 15 and the 5, greatest common factor is 5. All right, so you just know your factors from the numbers that ends up being there. Looking at the variables, if I look at the x's, all right, this is x to the fourth and this is x squared. Which one of those is smaller? X squared is smaller. That's going to be our common factor. And then for the y's, we have y to the third and y to the fifth. Which one of those is smaller? Y to the third. That's the one that's going to go into your common factor. So now we have to use the idea of adding and subtracting the exponents. So 15 divided by 5 is 3. 4 minus 2 is 2. 3 minus 3 is 0, so there are no y's. Minus 5 divided by 5 is 1, so we don't have to write that. X squared minus 2 gives us no x's. Y to the fifth, all right? 5 minus 3 is 2, so we get 1y squared, okay? So basically we're subtracting these exponents from those exponents to get to our reduced form. Okay. So if I look at something like this, 16x to the third, y to the sixth, minus 12xy to the fourth. First idea, what number divides both of these? Biggest number would be 4. So that's going to be in our common factor. Smallest exponents, we have to remember that there's actually a 1 as the exponent here. So x to the first. And then for the y's, which one of these is smaller? It's y to the fourth. So we're going to look to take the greatest common factor out of here. So 16 divided by 4 is 4. 3 minus 1 is 2. 6 minus 4 is 2. All right. 12 divided by 4 is 3, so minus 3. 1 minus 1, there's no x's. 4 minus 4, there's no y's. So there's actually no variables with this second one here. So taking out a greatest common factor is basically looking through, figuring out what's the most they have in common, and then writing that section out